Hello, everybody. My name is Eduardo Davila, and in my presentation is on major oxide models using monocrator data with the focus on how rhyolites in the area were formed through fractional crystallization, but intermediate compositions were formed through magma mixing. This first table here shows the composition of rhyolites gathered in the monocrator area. We see the rhyolitic composition trend of having higher silica percentage within the sample's composition. These next two tables are theoretical compositions of rhyolites, which were calculated to create the model so we can explain how natural samples were formed. For the models that we will see, we will have MgO on the horizontal axis because evolution tends to start with compositions with a higher MgO weight percentage. And as they evolve, they tend to lose that weight percentage. On the vertical axis, we will see other oxides such as TiO2 and a model between primitive and evolved compositions to show how rhyolites were formed through fractional crystallization and magma mixing. So this top table are the theoretical compositions for fractional crystallization and the bottom for magma mixing. So first model, we have MgO versus TiO2. The dots represent the composition. And here, this line is the fractional crystallization model. We see here, these are the primitive stages of the composition. Here is the evolved, and the model tends to explain how fractional crystallization formed these rhyolites in the early stages and in the end stages, but does not follow the trend within the intermediate compositions. So that's where we can use the magma mixing model to compare to the fractional crystallization model. And this does a better job at explaining how these middle compositions were formed through magma mixing. For our second example, we have MgO versus FeO. Again, we have our compositions represented by the dots and the fractional crystallization model here. Here are our primitive compositions and here are evolved. Again, kind of follows the trend in the beginning and in the ending stages, but falls short within the intermediate compositions. So that's where mixing model comes in again, and it does a better job at explaining how the intermediate compositions were formed through magma mixing. Here is our third and final example. Here we have MgO versus K2O. Here are our intermediate, or I'm sorry, here are our primitive compositions. Here are our evolved compositions. And this fractional crystallization model follows the trend pretty well up until it gets into the intermediate composition. And here's the magma mixing model compared to that fractional crystallization model. And it just shows again how it better explains the formation of these intermediate compositions. So in conclusion, I just showed the better models that I was able to create depending on how and the theoretical compositions were formed. These can be influenced by certain mineral compositions within doing these calculations. So depending on how little or of how high we want a certain mineral to be within the compositions can affect those models that we see. But that concludes my presentation, and I'd like to thank you for your time.